Hi everyone. In the last session, we completed the basic mesh for the SOFC cell, and without any separating any geometries, we made the mesh by applying different methods to different bodies, and we completed the mesh. In today's session, we will go towards a map mesh, which is a better method for meshing the SOFC cell. Here you can see at the gas channels, the mesh is really regular and even of much better quality. This is from the AFL and the thin layers, but the quality over here is much better than the we saw in the previous method. So today we will be making this mesh, and to start with this, we'll go back to the project window, and in the project window the first part is that we will duplicate it. So let's duplicate this geometry and mesh, and we will start from there. Okay, now for this mesh, because we need to make it a map mesh, so we will clear the generated data into this. So we'll clear the generated data in this component, and here we will make the map mesh. But to make the map mesh, as it's already defined in the guidebook, so in order to start with the map mesh, we need to go back to the geometric module, and in the geometry we need to divide the geometry into regular cuboid sections. So we'll split the geometry in different bodies, and for each body, for example the gas channel, we'll divide it into regular bodies which have got 8 corners. Likewise, we'll divide the interconnects, and after all the divisions have been done, we'll combine them and come back to the meshing environment. And after coming to the meshing environment, we will continue with the map meshing of these bodies. And finally, as you can see, we will be able to get a high quality mesh for using the map meshing methods. So here now we have cleared the generated data, and now we will go back and edit the geometry in the space claim. So the bodies that we need to divide in order to continue with the map meshing are the gas channels and the interconnects. Because we'll divide them into multiple bodies, it is better to have different components for them, not just a single component. So we will add new component, and let's call it interconnect anode, and we'll have another. Let's move this geometry over here, interconnect anode, and a new component for interconnect cathode. The next we will have gas channels anode and gas channel cathode. So we'll have a new component, and another new component, gas channel cathode. Now we made the components, so the interconnect anode, the interconnect cathode will go to the interconnect cathode, the gas channel anode goes to the gas channel anode, and the gas channel cathode to the gas channel cathode. Now we made the components, and within these components we will make adjustments. So let's hide these bodies. We have got we don't need to do anything with these geometries, but for the other geometries, let's hide them first, and let's finish the interconnect first. It is really simple to do the interconnect part. So for the interconnect part, we just need to split the body, and by splitting the body we will have different bodies. So you can go to the design and split body, select this body, and with this surface we will divide it. Now it asks select regions to remove. We don't want to remove any region, just press escape, and now we have all the interconnect anode bodies. So you can see interconnect anode 1 2 3 9. So now we have successfully divided all the anode bodies, and by default these are all regular bodies, so we can directly fit a cuboid into this. So the interconnect anode part has been finished. So let's go to the interconnect cathode part, and here using the same procedure we will split this body into multiple bodies. So we'll split the body, select the body, selecting plane, and escape. So this is also done. Now for the gas channel anode, now this is the tricky part. It starts from here. So let's go to the default view. Okay, the first part that we should do is that we should have the planes, because we want to mirror all the geometries afterwards. So the first part is that we should divide have the mirror planes. So we'll go back to the system and we will make the planes over here. So here, in order to make a plane, we need to select this surface and with control this surface and select the plane tool. Yeah, we made a plane in the center. And now again this surface and this surface, we can have a plane tool to create a plane at the center. Now this is actually in the center of the entire geometry. So we made a section in the display. We can have it a perspective view. It's better to have different viewing options. It makes more realistic display. Now the first part in making the gas channel anode, to modify the gas channel, is that we should divide it again. So let's start with the dividing part, and we will go to the design and split body, select this body, and this is the cutting plane, the small one here. And we want to not don't do anything, we don't, just press the escape key. We don't want to delete any of the parts right now. And then split this body and split body with this part. And right now we want to delete this part, because after splitting this part into multiple bodies, then we will mirror it to the opposite side. So now we further need to make, now let's make a sketch on how we should. Okay, okay, this is better. Now we can, we need to divide. We have already divided it. Now we need to make a sketch from where we will make different planes and split the body according to our desired locations. So we'll go to the sketch mode and select the surface and have a sketch mode. And here we should make a sketch. Make sure that you already have a clear view of what, how you want to divide your geometry into. So by starting it, let's start by just at this corner. We'll just split. Oh, sorry, I had to split this. Escape and sketch mode. Do this view and go to the sketching plane. Okay, here we will move the project to sketch. Okay, let's make a line and now a rectangle. We would only like it to be a small rectangle, not a big one, so it is better. Like somewhat over here. We can give it the dimensions 400 by 400. Now, now we can make a again a line Now you see all the 2D sections that will make are, it will have four corners for this circle at least. Now we want to extend it further. Now we can divide it further. So let's make a line, and here we'll also extend it to 400 microns, and from here this is okay, we can divide it till here, and we can make a line, extend it till here, and still now this section has got 1 2 3 4 5 corners. We need to divide it in such a way that it should have, all the parts should have four corners. One method is that we can actually directly divide one of the nodes, and like here somewhere, and but with this here at this corner the mesh quality will be really bad, so we don't want to do that. So so in order to have a better mesh quality, we should always divide the arc from the central point and to here, and then from here we have another distribution from the same node to the center point of this. So now with this, you can see that all the geometries will have, for all the sections will have four corners, and it will give much better quality. So we can end this sketch over here, and now we'll extrude all these to make surfaces. So in order to make these surfaces, we should extrude them. Not, we don't want to extrude the face, we need to extrude the edge. So we'll select this edge, and carefully orienting it is also really important, so we can have the, we can actually, yes, it is better. So now every edge is also visible, and we can select this arrow to extrude this plane. Make sure to carefully select the edges and not the planes. So I think with this we can have a good division in all the, for all the bodies. So let's begin with by dividing only this body into different bodies. So we will continue by making it. First we'll want to divide it with this mirror image also. So we'll split the body, select this body, and by the central image, and delete this part because we will mirror it afterwards in escape. So now we will split this small section into multiple bodies, and split body with this mirror plane. Okay, yes, now we don't want to delete any part. So this is one another body, and now we want to split it further. You see this body with, should have this plane first. Yes, okay, now split it further, select this body further. Okay, split again this body by this plane. Now you see we have got two bodies that we want to combine them together, so we can have the combine. simply this body. No, we need to split this body first. Split body, this body by this plane, and now we need to combine this body and this body. This is actually a surface. If you go to combine body, this body and this body. Okay, let's first do all the divisions. Let's divide this body, split body. Okay, split body, this body with this part. Split body again, split body again, this body with this plane. Now let's see the bodies. Okay, one, we need to divide this body, so let's divide this body again. Split body, this body we want to divide with this plane. Now again split. Let's which are correct. Let's keep hiding the bodies that are correct. So this body is okay, we don't want to make it any further, divide it any further, so we'll just hide. Okay, now this is okay. What about this? This is also okay. This is also okay. This is okay. This is okay. This is okay. And this is okay. But still, how come there's this body remaining? So let's check where is this. The final one, yeah, this is the one. So from 1, you don't want to combine it. Yeah, we want to combine these two bodies, so now we can actually combine these two bodies and we can delete these planes or uncheck these planes. I think we were in the gas channel cathode where all these are being made, so we can actually have these surfaces. We can actually move all these things. Okay, it doesn't matter anyway, so we can just have to show the bodies, and now we can combine these bodies. So this is the body and this body, sorry, combine. Okay, we need to combine these bodies, but here when we select one of the bodies, now it will go directly to the cutting plane, so we need to add it, and we add this. Now this is single body, so now we can take a look at all the bodies that we have for the gas channel anode part. So this is one part, this is the second, these are the three bodies now. And here, now this is the part that is actually, and if you go supposed to 5. Okay, now you want to have the to see the planes also, and we will mirror all these bodies in this plane. So let's go to mirror. First select the mirror plane and then start selecting the bodies. In this mirror plane, now we want to actually mirror the all these bodies to complete the anode channels, but it is important that we first activate the components that we are working on. So in order to do that, because we made different components, now we are currently in the gas channel cathode, so we need to right click and click activate component. Now on this, only by doing this, now we can actually do the mirroring task. So we'll select the mirror plane, and let's select the mirror plane. So now it says to select the body that we want to mirror. So we'll select this body and carefully select all the components. Now this part is done, so the bodies have been added, as you can see. Now we will add the all these bodies on the other side also, so we can actually just we don't want to continue with the mirror, so let's press escape key. Make sure that we don't have not mirrored any gas channels, so there's no overlapping geometry. We need to make sure of that. So this is hidden. 13. Yeah, and all these components we want to mirror them, so we can mirror them in this plane. Now we'll select the mirror plane in this and select body to be mirrored, so we can select all these bodies. Again, we need to make sure that we have not duplicated the bodies. That is important, that there shouldn't be multiple bodies in the same region. So cool. Now we'll select the original ones. So now how many components are there? So it should be 36 components in total. If we place them all, so there should be 36 components in total. Yes, there are more components. So on 2, 3, 4, 5, 6, 7, 8, 9. We have got 10 channels. These are two, and there are almost 40 components. 1, 2, 3, 4, 5, 6, 7. So it's 28 and 30. There are almost 40. Yes, so there are 40 components. So for this, our gas channel node has been completed. Now we need to do the same procedure for the gas channel cathode as well, and make sure that we activate that component also. So we will activate the component, and now we will start modifying this component in the same manner that we did previously. So let's go to the positive view, and we'll set it as the sketch mode. And now again, using the same strategy, we will split this section. Let's make a line and then rectangle. Enter here. Sorry. Yes. I think we made this line differently. So let's, from the center, it seems good. Sorry, previously we did from here to here like this. Yeah. Okay, so we can have any strategy to do the mapping which will be appropriate. So we can end the sketching mode, and so now again we will modify it like we did previously, and extrude all these surfaces again. Okay, so now this channel we first need to divide it again like we did previously, and here we will go to the split body, this body with this plane. We don't want to delete it right now. And then again split body, this portion in this plane, and now we will delete it because we will mirror it again. And now go back and we'll activate the mirror planes, and we'll split this body also. So let's go to split body, and we'll delete it. Now we'll start splitting the body in the desired planes. So split body, we don't want to delete anything, so just keep pressing the escape key once we split it. And this body we will have this plane, Now split body. Okay, let's go to this first, and we don't have this plane right now, so we should extrude it. Let's select this, go to the pull, select this line, and likewise select this line. That's good. Now I can go back to the split body, split this body with this plane, and then again split body, this plane. Okay, now we can have again a split body. So this is one, we need to split this body with this plane. Now how many split? So this is also split, this is currently split, and now we want to split this body, this plane, and then finally this body with this plane. Now we have all the bodies. If we go to the split body function, and now it will only pick the bodies, and we can check that all the bodies are okay. So but we need to combine these bodies, so we go to combine body, select this body, and with the plus sign, sorry, control Z, we don't want to add them, we had combine this body with the plus sign, this. Now it's okay. So if you go back to the split body, 3 parts. Okay, now we made a few slightly less parts in the cathode side. We had more divisions in the anode part. So 1 2 3 4 5 6, and now we can actually mirror all these bodies. So go to the mirror option now and select the mirror, and now we can select these bodies. Now these are all mirrored properly. Escape, and we want to hide these channels. Okay, now these are all the geometries, right? The 1 3 13. Yes, there are 13 bodies, and we want to have them mirrored in this plane. So got all the bodies on the other side also, and now if we count how many bodies we have, 1 2 4 5 6 7, one. We can delete these surfaces, we don't want them anymore. Okay, so now we have got 1 2 3 7 8 9 10 11 12 13 14 15 16 23 26 27 28 29 30 31 32 33 36. Yes, we have got 36 bodies in total for the cathode section. So with this we have finished all the divisions of the bodies, and now we can move on towards the actual meshing side. Now that should be very simple, but before going to the meshing, now we again need to share all topology. So we should share the topology, and now it will ask about, make sure to check again the tolerance, and now it even combines all the bodies that we have split. It will make consistent topologies within them. And okay, so now you can see all the bodies are shared. So there's a different type of distribution at the anode section and the cathode section. We actually made just one block out of it. So with this we can actually now save this section. So we can save project now and close the design modeler. You can close the space claim, and now we will continue with the meshing. So we can edit it. Yes. Now as you can see, when we open with the mesh, because we already had multiple things, because we duplicated the project and it is not empty, all the things are already there. So you can see there are not many problems that came up with by modifications of the geometry. So right now we will just unresolved scoping, and okay, just we don't want to fix them right now. We'll fix them everything right now ourselves. So you can just close it, and let's start again with this. So the first thing that we need to do is that to make the bodies section correctly again. So for that purpose, these things are correct, there's no problems in this, but the channel anode and channel cathode, they have been disturbed. So we go to the geometry section and select all the interconnects, which is the easy part. So we will select all the interconnect and node parts using the control key, select all the interconnect and node parts, and hide all other bodies. So now check if it is perfect. So okay, the better way is to delete all those bodies that are not correct. So we will, not the bodies, the named selection, so we'll just delete the named selections. I think these should be okay. We will assign them afterwards, the surfaces. But right now, for as far as this is concerned, now we will make a new named selection, and this is actually interconnect. No, delete it. Select the bodies only. Okay, so there are 10 bodies in total, and we will name it no, this is correct. So now we'll select interconnect cathode. So let's hide bodies in group. Now we have interconnect cathode that we want to make, so we will go and check interconnect cathode. So since this is all correct, so make named selection. named selection, and we will call it interconnect cathode. Now we are left with mainly the gas channels, so I think we should delete all this. We can rename, make these easily afterwards. And now we'll go to the gas channels. Let's hide all bodies, and now we'll go to the gas channel anode. So all the gas channels are actually connected, shown. So let's select all. Go to box select. Go to create name selection. Should select the name selection here, and now insert name selection, and this we can have as, and this is the gas channel for anode. Sorry. Gas channel anode. Now this is the gas channel that we have completed for the gas channel, and now we will move on to the gas channel cathode. So we'll hide bodies in group, and now go to the gas channel cathode. Now we'll again select the named selections, select all, set named selection, and F2 channel cathode. Now we have made all the bodies like previously. We have got AFL, ASL, but we have got the gas channels at the end. We should rename it to channel anode and channel cathode. Let's rename to channel anode, channel, because we previously did it like the same way, channel anode and channel cathode. Now with this we can create again the named selections. So we will have the mesh anode active flare, show hide all other bodies, and so anode is at the bottom, so on the top surface is the wall electrolyte. So create wall anode, and the next we want to make the inlets and outlets. So for this we need to show all bodies, and now in the positive x-axis we have the inlet anode. So here now you see it will be multiple bodies now, so multiple faces. So make sure to select the correct face and extend to limits. So you see that it has been extended to all the face. And inlet anode. Let's go to the, yes, we got the inlet anode, and you can see we have got three faces. Now inlet at cathode, extend to limits, inlet cathode. Now again outlet anode, and outlet cathode. Since the interconnect was distributed in multiple geometries, so again we need to define the current tab and the voltage tab. On the top is the current tab, and on the bottom is the voltage tab. With this we have finished the named selection thing, so we can finally see, like, hide all geometries. It is better to check repair overlapping named selections. So there's no, right now there's no problems. Okay, so if there's any problem it will just come up over here. So now we can continue with the actual meshing and sizing. So we can delete these methods now. Head sizing and sweep method, so we will follow the same routine like we did previously, and we'll go to the mesh and hide all these bodies and only show these bodies in this group. Okay, now let's go to one by one and start the meshing, because it is already included from previously. So we'll select one by one and go to the body selection, select this body, and I have selected the mesh, and now generate mesh on selected bodies. Now this is done. As you can see, we already have ping 0.05. It's very low quality mesh because it's very thin surface, so we're bound to have this low quality in this for this mesh. These are planar surfaces, so they can be meshed very easily. The problem, we need to have face meshing methods and sweep methods for the gas channels. So right now we will finish the meshing for the planar surfaces, and now in the geometry also you can see that we are finished with the meshing for all the planar surfaces, and we can hide these. So we can hide these bodies now, and the only bodies now we will be concerned is with the gas channels and the interconnect. So we'll first move on to the gas channel. So we'll show the body in channel anode, and for this we need to apply the face meshing method. So go to the mesh and insert method. uh, Select all the faces, apply. Now these are 40 faces. So we have applied a face mesh method on the gas channel, and for the same we need to have another method, a sweep method, for this geometry. Go to box, select all this geometry. So we have 40 bodies and method is sweep. Now we'll try to mesh this. Now you can actually hide this body, and this one is done. So we will go to the gas channel at cathode side and hide body channel node, hide. Okay, now again we need to apply the face meshing method. So we'll go to the mesh and apply face meshing to all these geometries. Apply, and we'll have the face meshing method on all this, and for the same geometry we will have another method like previously, a sweep method. Now go ahead and generate mesh on these bodies. So we will go and generate the mesh. And now we should show all the components, so we should show all bodies, and here we will go and see if the mesh is being done properly. So yes, so you can see now we have obtained a regular mesh for the gas channels, and because they were face map meshing is being done, so you can see the quality of the mesh in these regions. But here there's one problem, that here you can see the map mesh is not in particularly good correlation over here for. So you can have a regenerate mesh on this selected body. I have no idea. I think we missed it earlier, or we skipped it. It shouldn't be like this. This is bad. At the location we had less divisions, a much better mesh is obtained, but higher divisions, unnecessary divisions made it worse. Although it doesn't make sense, so we can clear the mesh and start again for because this should have been meshed earlier. So we'll start again. This type of problems can occur when you try to mesh all more items at the same time. So we'll clear everything again and try to mesh one by one.
입주자 여러분 안녕하십니까? 관리사무소에서 관리비 납부에 대하여 안내 말씀드리겠습니다. 오늘은 6월분 관리비 납부 방식입니다. 아직 관리비를 납부하지 않은 세대는 고지서 계좌번호를 기재하시고 오늘까지 납부하여 주시기 바랍니다. 다시 한번 안내드리겠습니다.
So
오늘은 6월분 관리비 납부
now we are generating mesh again. So make sure that all the planar surfaces are meshed before we move on to the gas channels.
감사합니다.
For now it is showing a proper mesh. So we'll go ahead and try to mesh the channels. And in the geometry we will invert visibility. Now we will we should hide this body also. And go to the mesh. Because you already have the methods, so it should make a proper mesh, a proper hexahedral mesh. Yes, as expected it made a very fine mesh, but here we could have done a little better, but the mesh quality even is not bad, it's good. Now you can hide this. And now we'll mesh all these bodies. For at the cathode side, there are few number of divisions, and the mesh is better compared to the anode side. Okay, now we should hide this body also, or we can show all and just generate the mesh. So show all bodies, see the mesh, only the interconnects are left. I think we should separately mesh the interconnect, but now you see the because we generated the mesh separately, now here the mesh is not slant, it is straight mesh, and now we can actually go and generate it. Yes, now everything is being corrected. So the mesh, but again the mesh quality on the cathode side is better compared to the anode side. You can see the bigger mesh size over here, and but the mesh has been the distortions in the mesh are completely nullified, so it's a very good mesh now. And we have obtained a regular hexahedral mesh throughout. As you can see, there's no other mesh labels that were present previously. And to check the mesh quality for the gas channels, so we should suppress all the other components. So yeah, so we'll suppress them temporarily, suppress bodies and group, and check for the mesh quality now. So we'll go to the mesh and check for the mesh metrics now, element quality, and you can see we are above 0.6, which is a very good mesh compared to previously, which I showed in the guidebook. We had a mesh quality of 0.5, but we are above even a quality of 0.6. To see, and this mesh is also really good compared to last time. We had some the lowest mesh quality was over here, but this time we improved it by making a slant division, so it gave more space for the mesh at this corner to be to have a better aspect ratio. So this is overall a very good mesh up to 0.7. So you're having a very good mesh till this point, and these are the lowest quality elements, and they are all above 0.6, so it indicates a very good mesh. Now we will activate all the components, activate all components. So let's activate all the components for physics, unsuppress bodies and group, and now everything is perfect. So I'll go back to the mesh, and this is the final mesh that we have obtained, and we will continue the analysis using this mesh. So we can save the project now, and we will move this file for the Fluent. Now we'll transfer this file to new Fluent and update the upstream components. Double click to start the Fluent, and we'll go for double precision 3D, and we'll use make use of 4 processors. Start. Now this is a very common problem. We got too many errors, so but it must be fixed. So because we did the edited the geometry and made different zones, now we need to go back and check whether all the zones are defined properly as fluid or solid domains. So we'll delete this component. We can and go to the mesh and revise it. So as I told earlier, we discussed also, so here when we make the solid entity, it will by default make it as solid. So except for, so here we should select all, define them as a fluid, and then the interconnects we can define them to be solid. So interconnect, so all the interconnects are properly shown. Check if, because this is the only, these are the only geometries that should be solid, and we will define them to be solid regions. And now save the project again, so it will write them to be properly as fluid or solid regions. Show all the geometry. Let's preview the mesh, and this is good. Now we need to reread everything. So now we'll transfer data to new Fluent, and now up again update upstream components. Now it will write properly the fluid and solid domains or the zones. Double click on Fluent. Yes, again double precision will make sure to make use of 4 processors. Start. Now see, we don't have any errors for the inlet and outlet zones because they are being defined properly as the fluid regions. The next thing we should always do is check the mesh. If it's good, perform mesh check. So everything is okay, and here if there would happen any problems, it would have mentioned it over here. And we always want to check the extents. If you go to the and there are no very small inaccuracies available present in the domain extents, so it is overall a very good, all the geometric to meshing and the import to the Fluent has been done really well. So this is it for this session, and for the next session we will continue with the analysis, colors and surface, and we got all the domains properly obtained in the Fluent environment. We can check the zones over here. We've got the fluid zones and the solid zones, and from this point we will continue the next session, uh, continuing with the simulation of the SOFC cell in the Fluent environment. Thank you.